Yeah, I'm Petr Dvorak, and I will be presenting some tips and tricks how to use Kicad for serious hardware development. Some people tell that Kicad is a toy for hobbyists and tinkerers, and I think it's a quite professional tool, especially in the lately released version 8. So I think Kicad is fast. If you move from another systems, you would be surprised how fast and how reactive the Kicad is. Kicad is flexible because it can be uh, fueled with many action plugins and yeah, extensions. It's an open system and affordable. For many of us, it's free. It's for $0 US dollars or euro or anything. But yeah, we can support developers by some money. But yeah, basically it's free. So I prepared a live demo for you. There will be 15 stages. We will be present in the schematic editor and then in the PCB editor. So let's switch to Kicad. Here is the stage 1. Let's see that the task is to change C20 to another symbol, another component. Of course, we can always do that. Yeah, we can delete the C20, find another one in the database and place it in the place of C20. But there is a more elegant solution for multiple reasons. So I recommend to use the change symbol feature in the properties of the symbol. So open the symbol properties by E key, and there is a symbol property window and the button change symbol. You can leave the checked change select symbols checked, or you can change the settings, but we want to change only C20, so keep the change selected symbols as is. Now I am looking for yeah, another symbol. Here it is. I recommend to check the value option because sometimes the value can differ and you don't want to keep the values from the old symbol. So voila, and the symbol is changed. The value position can be changed, so you can arrange it, and it is. So yeah, we started slowly, but that tool is really useful. Stage 2, multiple symbol change. I showed you that the symbol property can be used for symbol change, but not for multiple symbols. The task is to change C23 and C24 to 0402. So for instance, I will select multiple capacitors, multiple symbols, but the E key doesn't work because the property window is functioning only for a single symbol. Then when we want to change multiple symbols, we need to go to the contextual menu. So right mouse button, change symbols from the menu, and the situation is the same. Yeah, I will find another symbol. I recommend keep the value checked and change. That tool can be used for changing, yeah, both tools can be used for changing all similar symbols in the entire schematics, but it's a bulk change, and we don't always want to make bulk changes because frankly, I don't use it because once I don't know what's happening in the sheet number, I don't know, 15, I don't do that because it's a hidden change and it's a ticking bomb. So multiple symbol change, contextual menu, and change symbols. So let's see the stage 3. Link in labels. That feature was introduced in Kicad version 7, I think, and it's really useful. Let's say that we need to make the web link alive. So here, this is normal text label, and in the bottom of the text property window, there is a checkbox link, and then we can easily select the HTTP and place the URL in there. And now the link is alive. I'm not going to click and to move to the browser, but you can see that the link is alive. But not, it was even more important and useful is we can use the links to moving between sheets. So here is the similar text field. I'm going to its properties. I'm checking the link checkbox, and then I can select that I want to go to sheet 2. So now the link is active, and I can be moved to the sheet 2. Let's see. Yeah, this is sheet 2. It works. So really useful, for example, for hierarchical schematics when you want to navigate the user or the fellow engineer through the schematics, through the labels. It's really useful, and for instance, for engineers who didn't create the schematics, is really helpful to navigate through the design. So let's see stage 4. Stage 4 will be a little bit longer because there are 2 parts. Repeat the last item. That great feature was introduced in Kicad 7, I think, or 6. I'm not sure now. And I will show you in action. Let's say the task is create 10 labeled wires. The step A will be that I will be using the repeat the last item. So I will draw the wire for pin 1, and then I'm going to repeat the last action command. I have the keyboard shortcut Command I, and you can define your own shortcut. I think in the default setup there is no active keyboard shortcut, and I am hitting the key now. And as you can see, there are 10 wires in a second. Now labels. I place label, for instance, PA0 or PA1. To the wire, and I use the same command, repeat the last item. And you can see even the number is being incremented. So in a few seconds, I labeled the connector or anything. Now we are in Kicad 8. The Kicad 8 was released like a week ago, and there is a new feature called pin helpers. But before we first use the pin helpers, we need to check and to basically change some setup in the Kicad settings, because pin helpers function need. I will show you. Kicad settings, schematic editor, editing options, and this option in the section selection must be unchecked. Clicking on pin select the symbol must be unchecked because I want to be able to select only pins. Yeah, you can see I drag the left button pressed and all pins are now selected. Now I press the right mouse button. Pin helpers is on the top position, and I can place directly net labels. Yeah, net labels are here. Don't unselect the labels. Press G for dragging, and now the labels are dragged along with the wire. It's a faster, but you don't have the full control of labels, and yeah, there is not standard setup for the pins because now you selecting pins instead of symbols. So it's up to you. I think I will stick with the repeat last items approach, but the pin helpers can be time saver as well. Stage 5. Stage 5 is about assigning a net class to labels. I prepared a few subtasks. So now we need to create two labels. It's simple. Then create a new net class, because once we need to assign a net class, we need to create the net class, because the Kicad doesn't contain anything but the default net class, which is not useful for us in common designs. And then assign to the new net class to both connections, to both wires. So I start with labels. It's simple. Net 1, net 2, and the approach is we need to switch to PCB editor to create some new net class. The new net class is being created in or can be created in board setup window. The design rules under net classes section. As you can see, here is only the default net class. I need to create a new one, for instance, net A. I don't know. It doesn't matter. The name doesn't matter. Okay. Now I can switch back to schematics editor. Select the net label, and it can be confusing, but you need to press the plus button. And the initial setup is assigning net classes. So the name will be net class, and value will be the newly created net class. And here is the label for the net class. Again, I am going to open the net class properties. Here you can set the shape of the net class label. It can be italic, bold, it can be centered, it can be even hidden. I think the italic setup as a default setup is quite good because it differs from the net label shape. And the same I will do for the second label. So plus button, net class is the default position, default setup, value, net class A, net A. And here we are. So let's see stage 6. Stage 6 is about differential pairs. Differential pairs, similarly to net classes, need some attention, and the attention must be put on net labels. The default setup this cannot be changed is that the net labels for differential pairs must end with the plus and minus character, or with P or N character. In other way, or only this way, the differential pairs can work and can be routed. So let's place the correct net labels. I'm going to create, or I'm creating the USB plus and USB minus. So here are the labels. I'm switching to the PCB editor through F8 hotkey. It reflects all the changes from schematics to the PCB editor. Yes, update PCB. Close, and we need to be in stage 6. Here it is, and you can see the pin 2 and 3 are already labeled with USB plus and minus. And now we can start routing differential pairs. The hotkey shortcut is 6, but you can go to the menu, route differential pair, click on the label on the pin where the differential pair starts, and we can route our differential pair. So we have a differential pair, but we need to make some things. The usual things for differential pairs is that we need to tune length of the differential pair, or we need to tune the skew of the differential pair. Kicad somehow changed the approach of measuring the length. The previous version 7 was, in my opinion, more straightforward, but this time in version 8, the tune length works as I'm going to show you. So again, go to root menu or press key 8 for tuning length of the differential pair. And once you click the differential pair, oh, sorry, again. You can see there is a measured length, and I can change the length of the differential pair. In the contextual menu, there is a few helpers. The thing is that the commands are accessible only through the keyboard shortcuts, not from the menu, because once the tune length of the differential pair command is active, you cannot go to the menu because you would cancel the command. So increase spacing is by pressing the number 1, decrease by number 2, increase amplitude by number 3, and decrease amplitude by number 4. So, for instance, I want to, yeah, this is the new feature of the Kicad 8, that you can tune the meanders manually by the mouse. So you can see the online calculating the length, and it's quite handy, but it doesn't work always like easily and smoothly. You can sometimes look for the correct place where to place the meander. Yeah. Let's see how the tune of the skew works. The skew tuning is present behind the shortcut number 9, or from the menu, tune skew of a differential pair. And when you click on the differential pair, there is a new feature, as I said, in Kicad 8 for manually modifying the meanders, but it differs it cancels the function of the skew tuning. So I need to delete manually those meanders, those manually changed meanders and place them again. It doesn't work as smoothly as in version 7. You can see it, that it's not good. So I think I will go to the next stage because the link to link. I tried in the afternoon the features before the webinar. It works better, but frankly, I'm not satisfied with the change in version 8. I need to take a look at it. So I'm sorry, I apologize. Let's go to stage 7. Stage 7, block swapping. Let's say that we need to change some blocks, for instance, for logical devices, for operational amplifiers, for similar devices that is composed from the same blocks. So A to D and B to C. Of course, we can grab the A and make it this way, yeah. But sometimes it's not the great way, and sometimes there is a better way, and I will show you the better way. So let's say that I need to change the change back. So D to A and A to D. There is a property window for the symbol, and here you can see in the section general there is a unit section when there is directly possible to change the unit. So D to A and A to D. It's faster, more precise, safer because you don't change the position of the symbols. You can't change the connection because sometimes it can happen that you place the symbol like that and the connection is interrupted. So block swapping this way. What's the block swapping for? Well, once you create your schematics and move to the PCB layout, you basically are looking for the best connection and best layout. So sometimes it's very useful to have a chance to switch units of a device with generic parts because it can make the PCB layout easier. It can make the tracks shorter without routing, without crossings, without vias. So only the good things. So I recommend to manage the block swapping from the schematics the way from the property window. It saves time and it's more precise than the manual changing. Stage 8, pack and move feature. Pack and move feature, it's one of the features for the PCB editor during the component placement job. Let's see. Here is a snippet of a schematics. It's nothing that makes sense. It's just a schematic snippet, and let's say that I need to place some components on the PCB. So let's switch to the PCB editor. And here is the mass of the symbols of the footprints as you can see when the schematics is transformed into the bare and empty PCB layout. So let's say that I need to start with the power supply and with the blocking caps. So I just select the symbols, move to the PCB editor. The footprints are already selected. Now, I clicked the left button instead of the right, so I'm doing it again. Here it is. Power supply and symbols, PCB editor. And now right click, pack and move footprints is the command I'm looking for, or the key shortcut P. Now your footprints are packed. You can move it because they are sticked on the cursor. You can move them everywhere, place them, and start component placement only with your selected footprints. Really useful feature, especially for crowded and for designs with a lot of footprints. Let's see the stage 9. Stage 9 is another useful feature in the PCB editor, and the feature is filter selected items. I will show you how it works. I'm sorry. Stage 9. So here is a snippet of the PCB layout that doesn't make sense, just a demo. There are some tracks on top and bottom layer. And let's say that I want to delete all tracks on the bottom side. It's quite a simple. Yeah, I can select all the tracks one by one and delete using the delete key. But let's use the filter selected items, because once the layout is bigger, it's quite for a long time. So I said that we need to delete all the tracks on the bottom side. So let's make the front side tracks hidden. Select the entire section. So I selected all footprints, all tracks, and all vias. All, yeah, good idea. And all text items. Now the contextual menu, right mouse click, select, filter selected items. And here is a window for the selected items. I unchecked all items. And now I want to delete all tracks on the bottom side. So I check only include tracks, press OK. And only the bottom side tracks are selected. Now, when I make the front layer tracks visible, they are visible here now, but as you can see, only the bottom side tracks are selected. So I'm pressing the delete button and they disappear. So it can save a lot of time, especially during the redesigns, rework, engineering change, yeah, you name it. So let's see the tools. Pardon. Let's see the schematic editor, stage 10. Stage 10, create from selection in PCB editor. This is the command is called create from selection. And the task is create an array of vias in 5 × 10 composition, 2 mm times 2 mm from each other. This is a useful thing and a quite frequent thing for stitching vias, for placing vias on big copper polygons, copper pores. Yeah, you know the situation. So you can do it manually to set the grid to, for instance, 2 mm or 1 mm. and to place it one by one, but it's not what we need to do because 50 vias placing takes some time, and yeah, let's use some automated way of doing. So stage 10. Here is a prepared via. We can place a new one. I will use the current one, and the tool is accessible from the contextual menu. Create from selection and create array. There is a hotkey Command T on my Mac. I don't know if the hotkey is Control T on Windows or Linux or a different. I think Control T. So create array, and here is the window of the tool. We need 5 times 10, so 5 times 10, and the spacing will be 2 millimeters and 2 millimeters. So 5, 10, 2, 2. We are ready. Okay. Here is our via array. Quick, easy, fast, elegant, precise. Everything what we need. Do you know what's the great thing in Kicad? You can see that I chose the create from selection tool. So it doesn't need to be via. It doesn't need to be footprint. It can be anything. For instance, text label. Yeah, I selected stage 10 label, create from selection, create array. I keep the setup as is to save some time. And you can see it's nonsense now, but yeah, you can imagine the usage and the situation where your time will be saved. So this is Kicad, flexible, easy, simple, and fast. Stage 11. Let's see stage 11. What's the stage 11 about? Stage 11. Import DXF graphics in 1:2 scale as PCB shape. Ungroup the imported graphics. Okay. Let's see. I prepared DXF graphics in the Kicad, and the situation is quite common. You work with your fellow mechanical engineer, and your colleague designed the shape of the PCB, and you need to import the shape from his CAD to start with in Kicad. So for that, you need to go to the File menu, Import, Graphics. You need to select the file, the exported DXF. So here is the file, PCB shape DXF. Open. I need 1:2 scale, so it means 0.5. And I need it as a PCB shape. So I need to change the layer from user drawings to edge cuts. Here is the important checkbox I am going to talk about a little, ungroup versus group. Standard way is to import the shape of the PCB as grouped as a group when all the lines, arcs, everything is grouped together. So yeah, let's see. I will keep the group imported items checked, and I will show you what does it, how it works. So here is the imported shape, and now you can see that the shape is the entire group. You cannot change the position of the lines because they are grouped. So the solution is contextual menu with the selected shape, grouping menu, ungroup items. And now there is the group is over. It's not valid anymore, and the section, the parts of the shape is editable, accessible, and you can change anything you need. So it's a big time saver, because CADs like FreeCAD or basically any CAD that can export the XF graphics, which is basically every CAD, can export your PCB shape, and now you can import it. The shape is perfect, and it saves a lot of time, because Kicad is not so great for drawing for drawings. It's great for PCB layouts, but not for drawings. So let's see the stage 12. Stage 12 is about move absolute in the PCB editor and move relative in the PCB editor. Frankly, I think that this tool is one of the greatest commands in Kicad PCB editor. Let's see that we need to place those footprints 5 millimeters from those reference ones, 3.5 millimeter from the second group, and the 5 millimeters from them. So let's select the first footprint, and now we can use the move relative, which is Shift P, or I can select from the menu, positioning tools, position relative 2. Now we need 5 millimeters in a horizontal position. Do it again, horizontal position, 5 millimeters. 5 millimeters with a plus sign or without, like in positive way, means to the right, and -5 is to the left. So 5 millimeters to the right from the reference item. I can select the item. This is not the footprint. I selected only the text label. So again, here is the footprint, and now I'm ready. 5 millimeters from the reference footprint. Oop, it is here. The same with the second footprint. I need to select the new reference footprint. Here it is, and place. This is the quickest and most precise way how to position the footprints ever. Like it's the ultra tool. So I highly recommend to use the move relative. The move positive, the move absolute works differently, and it moves the selected item or selected items directly without reference item. So you need to choose the move exactly or move absolutely, move exactly. And now I selected this footprint, and I need to move it 3 millimeters to the right and 1 millimeter upwards, because the zero coordinate is the top left corner. So 3 millimeters to the right and 1 millimeter to upwards. Okay, and it happened. There you can see. It works like a charm. I love it. My tip for reference points. Let's see. We have the PCB corner, and we need to position everything from the corner of the PCB. So I recommend to place a via there. Why via? Because via is a simple and small target for the move exactly or move relatively tool. Let's see. Move relative, select item, and you don't need to precisely check the corner. You just click the via, and the via is now selected, And yeah, sometimes it happened that you select the wire, the line, the edge cut wire, the edge cuts line, but you need to select the via. It is like that. I am pretty sure you know the usage of the tool. So another stage 13. Find component movement using arrow keys and the mouse. This is another feature I love. Let's say that we need to move those two footprints vertically. So I'm hitting the M key for the movement, and immediately after that, I don't touch the mouse. I just press the arrow either up or down. Yeah. I change the grid now, and now I can move the mouse cursor, but the footprints are locked in the vertical position. If I cancel a command and do it again, I select the footprints, M for movement, and now I'm pressing the right arrow. Yeah, just once. And now I'm going to move with the mouse, and now the footprints are locked in the horizontal way only. I cannot move yeah, you can see that the cursor is moving up and down, but the footprints are locked in the horizontal position. This is the extremely useful tool for crowded designs where you need to precisely position the footprints without movements to the axis you don't want to use. So that's the find movement tool. Let's see another stage. Stage 14, polygon priority in the PCB editor. Okay, the situation is simple. You need a battery rectangle. It's a simulated situation, but let's say that you need the polygon bed connected with the network bed inside of the ground polygon, but you need them to be isolated, not in to be not I don't know how to say, like to be visible and to be separated. And now I need to render the polygons, edit, fill all zones. I don't know why the polygons are not visible now. Filled areas. I'm sorry. This stage doesn't work now. I don't know how. I don't know why Kicad stopped drawing and rendering the polygons. Oh, never mind. It happened. Stage 15. Create a Microvia, blind via, or buried via. The default option, the default window for the Microvias is in the board setup window. And each net class contains the setup for Microvias. And here you can see both net classes use the Microvia of 0.3 with 0.1 hole. And once you need to place the Microvia, you need to be in the routing command. So press X for the routing command, and in the contextual menu there is a option for place blind or buried via or place Microvia. Place Microvia. Now here is the Here is our Microvia. Let's see its properties. As you can see, here is for the reference the normal via. The Microvia is smaller naturally, but the Microvia has the different colors, and here is a setup for the Microvia. You can choose from the menu where you need to start the Microvia and where is the end layer. So you can simply change the end layer here, and the Microvia change to the inner two layer as I chose. You can see that in the top of the Microvia shape there is a top layer color, and in the bottom there is the inner two layer color. The thing is that once you need to place the buried via, I don't know why, but Kicad is placing the buried via as the normal via size, which is, I think, not really useful, because for HDI designs you need the microvias as blind or buried, because otherwise you just use the normal THD via. So my recommendation is to place the microvia with the needed dimensions, and then in the property windows change the start or end layer. Or you can use the command change active layer pair for routing, which is a small window here, and you can say that my active pair will be from front layer to the inner two layer, and now all your microvias will be placed from front to the inner two. Okay, this is basically everything about the microvias, and yeah, I think we are finished with the live demo. So let's see the Q&A section. John Willistein asked, is this only a live link for within the schematics editor, or also for an exported? It's functioning in the exported PDF as well, so it stays working. It works even in the PDF. Chet Seaver asked, what is the difference between length to link of differential pairs in 7 and 8? Yeah, the length to link in version 7 was that you set the target length for all the tuning process. For instance, you set 50 millimeters as a target length, and then once you tune the length of the differential pairs of all the pairs of you were touching, the target length was the set 50 millimeters. Now in the version 8, I didn't find that section for setting the final length, and you just tune the length, and you need to check the online length measuring tool if you are in the target or not. So I don't find it very useful, and I think it will change in some further releases. Sean Borman asked, how do you set a target length for a single? Yeah, this is exactly as I just explained. It seems to be gone exactly from the version 8, and I don't know why, because that was a really useful part of the process, because now you need to online check the length measuring tool, but I don't think so. It's a good step from the developers, and I believe it will be put back in the further releases. Sean Borman continued, I'm using 8 and found the length tuning to be pretty intuitive broken. Yeah, I am +1 to that opinion. Robert Marin, I noticed you are on Mac OS. Anything special to run on Mac? No, it runs smoothly. Yeah, I just started 10 years ago or so, and I wanted a system that runs without any updates that cancel your work for half an hour, and yeah, you know that situation. The Linux was the possibility, but after I quit after about 5 years of using it, I decided that I need the system to be ready to work, not to be tuned all the time. No offense to the Linux users. Sean Borman continued. Do you know a way to lock movement in only vertical or horizontal directions? Yes, I think I. You need like permanently lock only in vertical. If you mean permanently, it doesn't. There is no way how to do it. Only when moving items, as I presented in the live demo. Jakub Vyhnálek, the polygons are rendered because you already have a closed edge cuts somewhere else on the project. Yeah, you are probably right. In the demo. Yeah, you're right. Thank you for the explanation. Another question: which plugins are your favorite or must-haves? Let's see. My must-haves plugins are the interactive BOM. I use the BOM to push the designs to the manufacturing companies. I use the GLC plugin, GLC PCB plugin tools for my customers who wants to manufacture boards at the GLC PCB, including the PCB assembly. And the fourth one is Create Labels. It's called Keybuzzard. It creates nice looking labels for silk screen, and there are some small bugs, but the result from the Keybuzzard is great, and the labels looks perfectly. So Keybuzzard, interactive BOM, basically these two. I am not a fan of plugins. I want my tools to be in a vanilla stage, because after the upgrade I don't need to reinstall everything. But those two tools are a must. Do you have any pro tips on grids? Yeah, there are the grid settings changed in version 8, especially in the schematics. Now when you change the grid with the hotkey, let me show. There is a section grids in schematic editor setup, and you can set the fast grid switching, grid 1 and grid 2. And once you switch using the fast grid switching, you can see the actual grids, and you can place your own grid in the list here. So I place the user grid of 10 mils of there is already. So I was just testing it a few days ago, and I noticed that it works pretty good. So the fast grid switching is the pro tool I have, the only one. David Woods, do you have a method for persistent highlighting painting nets, including press? Yeah. I know what you mean, but I don't have. It's pretty unstraightforward way how to paint and how to change the thickness and color of nets. So I'm sorry, I don't have. Orpheus Mora, Alrighties. Have you tried the spice? No, I didn't. Frankly, I don't know why the developers spend so much time for creating the simulation tool inside the Kicad when we have the LT-Spice and the Q-Spice and other tools that are free. I think they should be focusing on the schematics and PCB editor functions instead of the SPICE simulators. I'm sorry, no offense. Does Kicad have online DRC? No, it's only after you choose the command, the DRC check or ERC check. Do you create your libraries? Yes, I use the project-specific libraries for my customers because along with the project files, I deliver the library files for all symbols and footprints used in the project. Okay, that's it.
Okay, I think that's it for today. Thank you very much for joining us. Thank you so much, Peter, for presenting this amazing demo. This was so great. Thank you very much. I will send you the recording tomorrow, and see you next time.
Thank you. Bye-bye.
Bye, everyone.